Welcome back. Today, we're tackling one of the most common challenges in embedded systems, making them fast and stable.
Okay, so let's just get right into it. This is a situation we've all been in, right? Your device is crawling, it's buggy, it takes an eternity to boot up, and you're just staring at it thinking, where do I even begin? It can feel super overwhelming, but don't worry, we're going to build a really clear roadmap to solve it. All right, so the very first step in any investigation is to gather evidence. And the best place to start, it's by listening to what the kernel itself is telling you. Seriously, think of it like the system's own private diary. It's writing down everything that happens.
So how does the kernel talk? Well, its primary way of communicating is through printf. This is the fundamental tool. Think of it as the system's internal voice, reporting on everything from drivers loading to critical errors. It's the absolute ground truth.
Now, this is where it gets really smart. Printf doesn't just shout everything at you at once. It uses these log levels to triage messages. You've got everything from a full-blown kern emerge, which basically means the system is unusable, all the way down to kern debug for super detailed info. This lets you cut through the noise and zero in on what actually matters. And how do you actually see these messages? Super simple. This one command, dmesg-w, is your golden ticket. It gives you a live, real-time feed of that system diary we were talking about. It's like watching the system's thoughts as they happen. Okay, so once we know how to listen, we need to start asking the right questions. We're shifting gears now from just finding bugs to hunting down what's slowing things down. We're looking for performance bottlenecks. Let's start with a classic, probably the most common performance complaint out there. Why does my device take so long to boot? It's a huge deal for user experience, right? No one likes waiting. Your investigation starts right here with this command, systemd analyze blame. It sounds dramatic, but it's exactly what it does. It points the finger and tells you precisely how much time each and every service is taking up to start up during the boot process. And boom, look at that. The output immediately highlights your biggest offenders. In this example, Network Manager is taking over 10 seconds. The crucial point here is that this tool lets you ask the important question, do I really need all of this running at startup? Maybe you don't need Bluetooth or a printing service right away. Disabling those non-essentials can give you a massive speed boost. Of course, it's not just about boot time. Once the system is up and running, you need to monitor its vital signs. And for that, these classic tools, top, htop, and vmstat are absolutely essential. They're like the EKG for your system's CPU and memory. But what if you need to go even deeper? For a much deeper dive, perf is the professional's tool. Think of it this way. Top tells you which room the fire is in, but perf tells you it's the toaster in the corner that's actually on fire. It can pinpoint the exact functions in your code that are causing CPU bottlenecks. Okay, so we found the problems. Now for the fun part, fixing them. Let's look at some concrete, high-impact strategies to get your system running at peak performance. This slide perfectly contrasts two fundamental approaches to how your CPU talks to other hardware. You've got polling, where the CPU is basically like an impatient kid in the back of a car going, "Are we there yet? Are we there yet? Are you ready?" It's super inefficient and just wastes CPU cycles. Then you have interrupts, which is so much smarter. The device just tells the CPU, "Hey, I'm ready now." This frees the CPU up to do, actual work. So here are some of the most effective strategies you can use. First, DMA, direct memory access. This lets your peripherals talk straight to memory without bothering the CPU. It's a game changer. Then, batching your reads and writes. Instead of lots of tiny, chatty conversations, you have one big, efficient data transfer. Using something like OverlayFS gives you a read-only file system, which is amazing for performance and the lifespan of your storage. And finally, TMTS. This is basically a chunk of your RAM that acts like a super fast hard drive, perfect for temporary files or high-frequency logs. Sometimes a really small change can have a massive impact. Check this out. By default, Linux keeps track of the last time a file was read, every single time. If you tell it to stop doing that with options like no wait time, you can cut down on write overhead significantly. It's a tiny tweak for a big performance gain, especially for flash storage. And hey, let's not forget about the network. You absolutely have to measure your actual performance to know where to even begin tuning. A tool like iPerf3 is perfect for this. It'll help you figure out your real throughput and where you need to optimize things like socket buffer sizes. So how do we put all of this together into a professional, repeatable process? We've learned to listen, to profile, and to tune. Now let's build the master workflow. Okay, this right here is the ultimate takeaway. This is your master plan for tackling any performance issue. It's a 5-step cycle. First, instrument. Add logging and tracing so you can see what's going on. Second, test. Put your system under a real load. Third, profile. Use the tools we talked about to find the actual bottlenecks. Fourth, tune. Make your adjustments. And fifth, and this is so important, validate. Prove that your changes actually worked. Instrument, test, profile, tune, and validate. That's the loop.
And that really brings us to this key idea. Remember, optimization is a cycle, not a one-time fix. You have to measure, tune, and then measure again. It's this continuous loop of improvement that leads to lasting performance. So there you have it. We've covered the tools and the strategy. We've built a powerful framework that you can use to make your embedded devices faster and much more reliable. The only question left is, what bottleneck are you going to conquer first? If you found this explainer helpful, and I really hope you did, please do me a favor and like, share, and subscribe to my channel for more deep dives into topics just like this one. Thanks for tuning in.